All right, hello everyone. Let's go ahead and get going for today. I want to start off by talking about a few logistic things for today. I'm sure you're all wondering about the exam that you took last week. I am so close to having those grades back out to you. I was trying to tie up some loose ends before class and just ran out of time. So those grades will be coming back soon. After class today, I have to go home and be a dad for a bit, so it is possible that I get it done after the kids go to bed later tonight. Possible. Probably more likely that I get it finished up tomorrow morning when I get back into my office. So very, very, very small chance you'll see those grades come back tonight. Very, very, very big chance you'll see them come back tomorrow morning. And the usual stuff that applied last exam will apply this time too. You'll have chance to submit regrade requests and the whole deal. The other thing that I wanted to make you aware of is the fact that we're kind of getting close to the end here. There aren't many weeks left, aren't many classes left. So next week is Thanksgiving break, of course. And we only have 2 new topics that I'm going to be introducing to you in this class, one of which is today. So today we have inheritance. We have one more new topic which I'm planning to do next week on Monday right before break. And then after that, it's just wrapping up the assignments. And of course, we have another exam at the end of the semester on the remaining material. But we're getting very close to the end here. So please, if you haven't already, kind of take a peek at the calendars. Make sure you know what's coming up. And also take a peek at the grade book on Canvas. If you have grading issues, if you have stuff that's going on, that you think needs to be fixed, I would definitely like to get that fixed sooner rather than later. So please let me know if you see any issues in the grade book or anything like that that you need to talk about. Does anybody have any questions about the last few weeks of class or exam 2 or any thing related to the calendar before we hop into today's topic? Any questions? Alrighty, great. So let's go ahead and hop into today's material. Today we're going to be talking about a very interesting and important concept. The concept of inheritance is on our agenda for today. And so kind of like we saw with recursion a few weeks back, this is another topic where if the stuff that we talked about with objects is still not sitting super well with you, then the stuff that we're talking about today with inheritance is going to be pretty tricky, if not impossible for you to absorb. So that's not meant to scare you, that's just meant to be realistic and be practical. If you're still kind of getting used to the idea of working with constructors and instance variables, calling methods on objects, definitely take some time, make sure you really solidify those concepts before hopping too deep down the inheritance stuff, because it's important to understand what those things are to understand what inheritance is doing for us. But what I would like to do today is start off just kind of giving you a general description of what inheritance is, why we like it as programmers, and then we're going to jump into just as many code examples as we can for the rest of the class. So inheritance, the reason why we like inheritance so much, the reason why inheritance is such a big deal within the field of computer science is because we like to be able to reuse code. We like to be able to write something one time and be able to reuse that thing many, many, many times. I know that personally as a programmer, I really don't like it when I have to write the same code over and over and over again. And inheritance is a good tool that lets us do that. But it also, I think, is a good way of modeling our objects. And really what inheritance tries to do for us is provide a way for us to talk about objects in different ways, in different contexts. So what do I mean by that? I mean that here, right now, sitting before you, I am an instructor, right? I teach, I answer questions, I call on people when they raise their hand, right? I do instructor stuff. When I go home, I am a parent, right? I tell my kids to eat their vegetables, I make them, go to bed on time. I do parent stuff, right? And there are other times when I'm not acting as either an instructor or a parent. I'm just a guy, right? But in all of those cases, I am me. So at some points in time, I'm doing instructor things, and some points in time, I'm doing parent things, and some points in time, I'm just doing regular person stuff, eating, breathing, sleeping, right? In fact, all of the time I am a person, correct? It's fair to say that instructors are people, right? Students are people, parents are people. So inheritance is a way that we use to draw those kinds of associations between objects. Inheritance is a way that we try to recognize the fact that a lot of the objects that we're going to want to create are going to share similarities. So how can we leverage those similarities? We're going to use inheritance to help us do that. Another example that I like to use a lot of times is to think about animals or mammals, right? There are a lot of things that all mammals have in common. We eat, we sleep, we breathe, we have hair, right? But then there are things that make certain mammals unique. Obviously, humans are unique from elephants and from dogs and cats. But then there are some animals that are very similar to each other. So if I talk to you about lions and tigers, right? Lions and tigers are different, yes, but also very, very, very similar. They're both cats. So what does inheritance allow us to do? It allows us to abstract out that stuff that is in common to both lions and tigers and say these are things that all cats can do. And a lion is a cat, so a lion can do all the stuff that cats can do. And a tiger is a cat, and so tigers can do all the stuff that cats can do. And yes, lions are different from cats, so they can also do all of this unique lion stuff, right? It gives us a way to keep all of the common stuff in one place, and then the unique stuff in all of the unique places where it needs to be. So that's kind of our main goal. Instead of just me yakking about it, let's take a look at some code examples. Hopefully it'll help to see some actual code examples. In fact, we're going to start with one that's kind of similar to what I was just talking about. Here we're going to take a look at a class called a person class. There's no inheritance happening here yet, okay? So I want to be clear for starters that we're not using inheritance yet. This class is very, very basic. It has one instance variable for the name. It has a constructor here that sets the name. There's a getter and a setter for the name, and that's it. I'm not too worried about having a whole bunch of stuff here, right? We're just trying to talk about inheritance. This class, the person class, is what I'm going to refer to as a base class. So a base class is a class that is inherited from. So that is what we use as the basis of our inheritance. This is the code, or the base class contains the code that I want to be shared, the code that I want to be reused across many different classes. So let's take a look at another class now. I'm going to switch over to the employee class. And right up here at the top, we start to see inheritance at work. So that keyword that we see, extends, that keyword means that we are using inheritance. Inheritance is happening here. More specifically, it's saying that the employee class is inheriting from the person class. All right, so let's talk about what that means. What does it mean to inherit from the person class? When we inherit from the person class, or when we inherit from any class, any instance variables that are in that base class and any methods that are in that base class are automatically carried over and put in to this class that is doing the inheriting. The class we're in now, the employee class, I would call this the subclass. So a subclass inherits or extends from a base class. And what that means is that all instance variables and methods from that base class are automatically then part of the subclass. Notice that there's no field name defined here for an employee, right? There's no private string name. That field does exist in the employee class, though. That field has been inherited from the person class. There is no method getName that is defined inside of this class, right? But that method does exist in the employee class. It was inherited from the person class. The getName method does exist in the person class right here. And because the employee class inherits from the person class, it also has the getName method. It can also use the getName method. And I can show that to you right down here. We construct a new employee object, and then we print out the name calling getName, right? Again, there is no getName method defined in this employee class. So the only way that it can do this is if it's accessing the getName method from the base class that it is inheriting from. Okay? The other stuff that we see in the employee class, so you see there are some fields here. One of them is static, in fact. I'm not really interested in getting into static versus non-static today. That is an important conversation, but not one for today necessarily. Come chat to me in my office sometime if you need a refresher on static versus non-static. What I'm more interested in talking to you about today is the fact that these instance variables only apply to employees. They don't apply to persons, right? So inheritance is kind of a one-way street. Right? Everything from person has been put into the employee class. But this stuff is unique to the employee class. So all the common behavior goes in the base class. Anything that is unique to employees is going to go here. Okay? So this employee class actually has two non-static fields. 3 fields if you count the static one, right? It has this ID number field, and it has a name that it's inheriting from the person class. So 2 fields. Let's talk about the constructor, because that's what comes next. What's the constructor's role again? Constructor has one job. What's the constructor's job? I said this like a bajillion times when we talked about objects. Yeah. That's what it does. So you're absolutely right. The constructor creates instances of an object. How does it do that? What role does it play? What code do I expect to see in the constructor for an object? Yeah. Initiate. You're right. Instance variables. That's right. The constructor's role in life. It has one job. That's to make sure that every instance variable has a value, is properly set. That is still true. That is still true here. Okay? The difference that we have to worry about now is where those fields are coming from. So this employee constructor is responsible not just for setting the fields that are defined right up here, but it is also responsible for defining the fields that it's inheriting from the base class as well. We can't ignore those. Those still exist, and we're still responsible for those. The good news is that we're going to start reusing some code now, using inheritance, starting with this constructor. The constructor in the base class, the constructor in the person class, already does a good job of taking care of this name instance variable. So we can reuse this to take care of that instance variable for us. And then the only other instance variables that we have to worry about are the ones that are unique to the subclass, the employee class in this example. And so here is the first example we're going to see today of another keyword related to inheritance called super. Anytime you see that word super, I want your brain to think base class. Base class. The super keyword is referring to the base class. That's what it's doing for us. In this particular case, what am I doing with the super keyword? I am calling the constructor. This is quite literally calling the person constructor. Okay? So I'm going to take the name that was passed in as a parameter to the employee constructor and just pass it right on to the person constructor. That takes care of one of my fields. The person constructor is going to take care of the name field. I just have to take care of any other fields which are done directly afterwards, you can see down here. So again, the employee constructor has to make sure all of the fields are set. We're going to take care of the ones in the base class by calling the base class constructor, and then take care of any additional fields that we need directly, just like we would in any other class. Is that clear? Does anybody have any questions about that? Yes?
I just have a question.
Sure.
Fields. Like, isn't fields scope?
I'm sorry. So I use the word field and instance variable interchangeably. They mean the same thing. I've been trying to force myself to use the word instance variable because I know that's what's in the text. But when I say the word field, I mean instance variable, and I'm trying to catch myself and say instance variable every time. So hopefully that clarifies. Yeah. Any other questions that I can address before we move on? Okay, so let's try another little example. We're going to actually code it up this time. So unlike this example kind of gave us all the code and we just kind of looked at it. But let's try another example. This time our base class is a rectangle. So rectangles have a length and a width. That all makes sense. There's a constructor here that accepts the length and the width. And we could have used standard draw, but for the purposes of this very simple problem, we decided to just use little stars to print out the shapes instead by printing them. It's not really that big of a deal. I don't really care about what this code actually does. I'm more interested in talking about the inheritance. So shapes are a common example when used with inheritance, and this is a pretty classic example of using inheritance. A square is a rectangle, right? That's one of the things you learn about in math class. And that phrase that I just used, that relationship that I just used, is an important one. That phrase is the relationship that I would use to describe inheritance, to describe something inheriting from something else. So when I say square is a rectangle, quite literally that means that square should extend rectangle. Or you can think of it the other way around as well, right? You're asking yourself, should this class inherit from this class? Say it out loud. Blank is a blank. If it makes sense, then inheritance is a good idea. If it doesn't make sense, then inheritance is not the right tool to use. Square is a shape. If I had a shape-based class, inheriting from that would make sense. Square is a person? No, that doesn't make sense. Student is a person. Sure. Employee is a person. Sure. Instructor is a person. Sure. Lion is a person? No. Lion should not be inheriting from the person class, right? You can literally say it out loud like that and use that as a guide to help you determine whether inheritance should be used or not. Very, very, very useful tip. So here we quite clearly are saying squares are rectangles. So what does it mean? Again, when I use inheritance, that means that this square class automatically gets all of the fields and all of the methods from the rectangle class. I don't have to write them here. They're just automatically given to us from inheritance. I'm actually going to skip this part about the no argument constructor. I'm actually more interested in this one down here. I know this isn't a math class, but consider that a square is a rectangle. The biggest difference is just for a square, the length and the width are equal, right? They're the same. So a square doesn't have a length or a width. It just has a size, or I guess you could just call it a width, or whatever you wanted to. So think about what that means for us in terms of inheritance. We still have to make sure that all of the instance variables get set. It's still our responsibility. The instance variables that we have, I don't see any here, right? None in the square class. So the only ones we have are the ones that we're inheriting, length and width. And we just said that for a square, those should both be the same. Those should both be the same. So maybe what I can do is call this constructor and plug the same value in, and that should create a square for me, right? Plug the same value in for length and width. Okay, how do I call the constructor of the base class? Super, width. Just plug the same number in twice, right? I'm going to plug in the width for the length, and I'm going to plug in the width for the width. This will call the constructor of the base class, set both fields. There are no more fields that we need to worry about. This class doesn't actually contain any additional fields. We're done. We've used inheritance to make a square class from a rectangle class. And if you want to prove it, we can come down here and uncomment out this code and see what happens. We draw a little rectangle up here first, and then we draw a little square down here after that. Right, here's our rectangle up top. Here's our little square down here at the bottom. Again, I want to point out the fact that there is no draw method in this square class. if you look here, there's no code that defines a draw method, yet I'm able to use this draw method on a square because it gets inherited. It gets inherited from the base class. So when using inheritance, one of the things that I want you to remember when using inheritance, if I am extending a base class in the constructor, this is almost always going to happen. I'm almost always going to start out by calling the constructor for the base class first. So you can just automatically kind of put in the word super and then figure out how to call that constructor properly. That's step one. Step two is to then make sure you take care of any additional fields if they exist. Okay? Question? Yeah.
Question. So, what is the difference by calling super with and then just rectangle with? Can't I use the same field as the same variable instances? It's just variables and not
Like this, you mean?
yeah.
Okay. So this is actually going to create a new instance of rectangle and give it back to you, whereas super is used to initialize this instance of a square. Does that make sense? It's a good question. It's an interesting question. The answer has everything to do with inheritance. Though if you just call the rectangle constructor directly, right? This has nothing to do with the base class. This has nothing to do with inheritance. You are just creating a rectangle, right? That's not really what we're trying to do here. We're trying to set the instance variables. We're trying to use the constructor of our base class to set the instance variables. That's what super does for us. It does not merely call the constructor, right? It uses the inheritance relationship to set those fields for us. I know it's confusing. It's complicated, right? I understand why you would ask that question. It's a very good question. Any other questions I can address before we move on to some more examples? Okay, so let me paint another scenario for you. When we inherit from a base class, we get all of it. So if there are 100 fields and I inherit, then I get all 100 fields. And if there are 100 methods and I inherit, then I get all 100 methods. Okay? I can't pick and choose. It's all, I get all of them or I don't inherit. I just don't inherit at all. Those are my options. So you can imagine that there are some situations in which, you know, I really want to use inheritance. There are maybe like 10 methods from the base class that I would like to use, but then there are a few other methods from the base class that just don't work for, you know, what I'm trying to do. It wouldn't make sense to inherit those methods because the subclass that I'm making would do those things a little bit differently, right? Would have those behaviors operate a little bit differently. That's okay. That's actually very common. In that situation, the subclass has the ability to do what's called overriding. So not overwrite with a T, override with a D, R-I-D-E. So by overriding a method, what we are doing is saying, I don't want to use the method from the base class. I'm going to make my own version of this method to use instead. And I want to use that version of the method. It's actually a very, very, very powerful tool. Still allows us to inherit things that we want to and gives us the flexibility to tweak or change the stuff that we've inherited that doesn't apply directly. So let's take a look at what overriding looks like. It's actually very, 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 very simple to do. This is an extremely, extremely trivial example. Here's a greeter class. You can see there's a method in it that's called greet, and it just says hi. Doesn't get much simpler than that. Here's a mean greeter class, and you can see that it also has a method in it called greet, but this greeter is mean, so instead of saying hi, it says go away. This is an override. You might even actually see this occur in the code. It's somewhat optional, so you won't always see this appear, but sometimes you will. This is called an annotation. It doesn't actually do anything. It's just like a little note that you're leaving to yourself. It says, yeah, I'm overriding a method here. But if you override this method, then this method will be used instead of this one if I'm using the mean greeter class. So if we come down here and take a look at the examples, you can see the first greeter that we create is just the regular nice greeter. The second greeter that we create is the mean greeter, and we call the greet method on both of them. So even though we inherit this greet method from the generic greeter class, because the mean greeter overrided that method, we actually see its version get displayed when that method is called, instead of the one from the base class. So here you can see that, okay, we print out the nice message followed by the mean message. If we come back to the mean greeter and we don't override this method, if this code wasn't here, I know this class is kind of useless now. It's quite literally empty, doesn't do anything. But think about how that affects this code, right? Now, when we call greet on the mean greeter, I took the overridden method away. So what's it going to fall back to? It's going to fall back to the one from the base class and use that one. So when I run this program now, right, you can see it gives me hi twice. So we override methods when the method that we inherit from the base class does not do what we want it to do. Gives us the ability to toss it out and provide a better version for our purposes. We all good? Any questions? All right. Let's talk about that word super again. We're going to return to our person class. This time we're going to talk about foods. So here we've created a very generic person class with a name, and this time they've included a getFood method that just returns hamburger because this is a very American person class. And what we would like to do is provide. Sorry, let me back up and start over again. What I was about to say. Sometimes what the code that is provided to us in the base class does part of what we want it to do. We just need the subclass to do something a little bit extra, do a little bit additional. So just like we saw with the constructor, we use the super keyword to refer to the base class. We can use the super keyword to refer to other methods from the base class as well, besides the constructor. So this is a common example of why we might want to do that. Let's switch over to this student class. You can see that it extends the person class. It also overrides the getFood method, but instead of replacing the behavior, this line right here, the very first line actually says, okay, go to the base class and do that getFood method first. Do whatever's there first. And then whenever you get back, I want to tack this additional piece of information on the end. So we have the ability to still do what we did in the base class and add some additional functionality from our subclass, should we want to. I believe there's yeah. So here we can see this person is a student. If I print out the result of getFood as a student, you can see that it's got both parts. But if I switch this to just a generic person and run the program again, we're actually calling the method from the base class, so you can see it just gets hamburger. I think what's interesting though about this, let's see if we can walk this through the debugger. I haven't done a debug example yet today. I think it's important to step through this code, see exactly what's going on. I've switched this back to be a student like it was originally, and I'm going to go ahead and start it up in the debugger. I set my breakpoint on line 19. And I'm interested to see how this getFood method behaves with inheritance. So you can see the first thing that it says to do is to go to the base class and use that getFood method. So when I step through the debugger, look at where we are. I'm now in the person class, right? I called the getFood method on the student class, and then it sent me to the base class. Super is what we use to access the base class when we're using inheritance. So once this is done, we return back to the subclass. We take the result that we received from the base class, and then we add on whatever additional information that we want and print out that result. Okay? So when it comes to using super in your code, there are more things that it can be used for, but I've shown you what I think are the two most common places where you're going to see it used. The first is the constructor. In fact, that's probably the most common place you're going to see super be used, is the constructor. You're almost always going to want to use the base class constructor when using inheritance. This version of using super to call methods from the base class is less common, but still used. Still a useful technique. Any questions? Yes?
I am wondering about objects. Like, I have a P, for example, in the subclass object, then this P is going to have all the instance variables from its superclass, right? Or
Yes?
and then if I have an object in the superclass, would it have the same instance variables of the extended class, or it won't, unless it's overridden?
I think you lost me. Can you?
If I have the object in the superclass, can it have the instance variables from the extended class?
No. No, inheritance is one way. So I inherit from the base class to the subclass, but not the other way around.
So it can be override.
You can override methods from the base class in the subclass, yes.
So that's methods, not instance variables.
Correct, yes.
Okay.
Yeah, you can't override instance variables. That's not a thing, yeah. Mm-hmm. Any other questions that yeah.
Can you just explain overriding again?
Overriding, yeah. So overriding is basically an inheritance. When I use inheritance, I get all of the methods from the base class. Hopefully those methods still apply and are still functional to the subclass, but it's possible that I might want to do things a little bit differently with those methods in the subclass than how I did in the base class. So overriding allows me to ignore whatever version of that method exists in the base class and have my own version of it in the subclass.
Can you explain, walk me through the code a bit of an override one?
I mean, this is an example of a method that's being overridden. The getFood method exists in the base class. It exists in the person class. We're saying that, well, I want to define my own version of this method for the student class that does something different. In this particular case, it does everything that it does in the base class plus a little bit more. That may not always be the case. It might be that you wanted to do something completely, entirely different. It's up to you as the programmer to make that decision based on what you want your program to do. I don't know if that answers your question, I hope. But yes, this is anytime I see the same method appear in a subclass that already exists in the base class, I am overriding. I am choosing to ignore whatever is in the base class and use whatever's in the subclass instead. It's confusing. I understand why you're asking. Totally valid. We'll keep doing more examples. Hopefully it'll start to make more sense. Any other questions before we do some more? Yes, over there.
When you wrote at override, is that necessary in order to override a method?
It's not. No, I included it because you will see it sometimes, so I just kind of wanted to explain what it was in case you see it. I don't believe it's required, though. I could be wrong about that, but I don't think it is required. All right, so I've got one more kind of code reading example and then a big code writing example to sort of end out the day. So we're going to use person and student one more time. This is the last time we're going to lean on this person class for today. I know I've been using it for a lot of stuff. But what I want to talk to you about next is It actually has to do with overriding, as a matter of fact. So if we take a look at our person class, you'll see that it contains a method called toString that just returns the name, right? The only instance variable that exists. And the student class, which inherits from person, also includes a method called toString that does everything that the base class version does, but also includes the student's ID number. So the person doesn't have an ID number. We don't know if they're a student or not, if they're just a regular old person. But student has an ID number, so we'll make sure to add that, right? So here's the question, or here's rather an interesting situation to think about. A student is a person. I've used that is a relationship before. I'll use it again, right? A student is a person. We can take that idea and extend it out. Anywhere that I have said that you can use a person, since a student is a person, right? I could use a student in that place if I wanted to. Or think about it this way. Here I see a parameter to a method. The type of that parameter is a person. It's expecting a person object, right? But a student is a person. So if I pass in a student object as a parameter to this method, that's okay. I can do that because a student can do everything that a person can do. It inherits from person, right? That's a powerful, powerful, powerful technique. Take a look at this code down here. You can see that we create a person and we create a student, and then here I pass in the person to this method, and then here I pass in a student to this method, right? Here I pass in a student to this method. So the question is, what gets printed out? Let's walk through the debugger and talk about this. Talk about this problem. Where am I? Oh. All right, sorry. Let's try that again. Clicked the wrong button, I guess. Here we go, much better. All right, set my breakpoint on line 15, and here I am. I'm about to step into this print method, and I'm passing a person. P is a person, it's defined as a person. So if I step into this, and I print out P, the question is, which version of toString am I gonna get? Am I gonna get the one from the person class, or am I gonna get the one from the student class? Well, in this case, I hope the answer is pretty obvious. This is a person. Person is the base class. We're gonna get this one. It doesn't even have an ID number. Person objects don't have ID numbers, right? So when it prints out this object, we're just gonna see the name. We're not gonna see any ID numbers or anything like that. We just see the name. Okay. Now we're gonna call this method again. This time we're passing in S, which is a student. The method is expecting a person, but passing in a student is okay because a student is a person. But here's the question, right? I step into this method, here I am. P is a person. I want to print it out, but which version of toString am I going to use now? Am I going to use this one, or am I going to use this one? The method thinks that P is a person because of the parameter, but we know that it's actually a student. And if you look at the debugger, you can see that it's actually keeping track of the fact that it's a student. So when we print out this object, what we see is that even though we're treating it like it's a person, it knows under the hood that it's actually a student and will use the overridden method from the student class. That's a very, 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 very powerful, powerful technique. When you override a method in a subclass, that version of the method is the version that will get used. Always, 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 always. I know that's a difficult concept, a confusing concept, a very abstract one. Question?
So if it gets convoluted like this, why would I ever want to override a method? Why wouldn't I just name in the student class
If you change this name to something else, then this method no longer works for both person and student. If the name of the method is not toString, it's toString student, I can't have both of them here, right?
Right. So you just name it one thing and then you use it with multiple classes?
Exactly. Yes, that is exactly right. That is the jackpot. That's what we want. That's what we want. We use it with multiple classes, and not only that, but the computer is smart enough to use the right one for you, basically. Yep, if you do it properly. I know it's confusing, I know it's abstract, it's difficult, but it's very powerful, very useful, and will start to make more sense with more practice. In fact, I'd like to do a coding example that I think will maybe even do a better job of illustrating that idea than this one. So let's do that. That's going to take up most, if not all, of the rest of the time that we have for today. I want to spend the rest of the time today doing a coding example with inheritance, hopefully using a topic that everybody is familiar with. We're going to be talking about bank accounts. So there are different kinds of bank accounts, right? Bank accounts for different purposes. But all bank accounts share some features, some functionality in common, I would argue. And so when you're faced with this situation, again, I'd like for you to remember that base classes are what we use to keep the, to organize the common functions, the common features. So anything that I can think of that all bank accounts have in common is going to go in the base class. And then anything that's unique to a specific type of bank account, like a checking account or a savings account, will go into those unique classes. So let's talk about bank accounts. I know that not all of you are business majors, bankers. I'm not a business person either. I know very little about money. Don't take this conversation as any kind of, I'm not a business guy. I know enough to get by. But I do understand bank accounts, at least enough to have this conversation with you. I want to talk to you specifically about checking accounts and savings accounts, right? So the difference between a savings account and a checking account, I know that different banks do things differently, and they're not all the same, and you can always go find different things. But for the purposes of today, we're going to say that savings accounts, they provide interest. That's I know that the interest rate is like close to zero, but that's one of the differences between a savings account and a checking account. They give you interest every month on how much money you've got in that account, whereas checking accounts generally do not give you interest on the money that you've got saved in your bank account, right? Checking accounts, what do they do differently for us? They typically allow us to do things like overdraft, right? I can withdraw more funds than I actually have in my bank account if I want to. A lot of places offer stuff like that. You have to pay a fee, but they let you do that. You usually can't do that with a savings account. It's not possible. I know some banks do things differently, but generally that's the case. What can both savings accounts and checking accounts do? They can do general account stuff like making deposits, making withdrawals, things of that nature. So what I would like to do is to write some code that reflects that and uses inheritance as much as possible so that we don't have to rewrite a whole bunch of code over and over and over again. So let's start with our account class. This is going to be our base class. This is the class where we're going to be inheriting from, where all of the shared code is going to live. Any code that's going to be shared, distributed across the subclasses, lives in the base class. It's already been started for us, but I think there's more work that needs to be done here. We've got some instance variables, one for, I guess that's the name of the account holder, and the balance. That all makes sense to me, right? But we need some behaviors. We need some methods. We need some actions that I expect accounts to be able to perform, specifically the ones that I mentioned a moment ago, depositing and withdrawing funds, right? So let's make some methods for those. If I deposit an amount in, we can keep it simple. I'm just going to add that amount into my bank account balance, right? It's not complicated. For withdrawals, I think it is a little bit more complicated. Because I don't want to allow people to withdraw however much money they want, right? They have to be limited by how much is in the account. So, if the amount that I wish to withdraw is less than the balance of the account, right? I should be safe to perform that withdrawal. If the amount that I'm trying to withdraw is more than the amount that I have in the account, I'm probably just going to ignore it and be like, nope, sorry. I cannot give you $2 billion. It's not possible. You're not Jeff Bezos. Okay, so if we get here, we'll just deduct the amount out of the account that they requested, right? I've not done any inheritance yet. I'm prepping my base class, and we're going to do some inheritance in a little bit. I'm coding up the methods that I want to be shared, that I want all bank accounts to have. So what I would like to do real quick just before we move on is maybe come down here and test a little bit, just to make sure that we understand what's going on. Okay? So what I'm saying is that if I try to withdraw more money than I have, right? My account started with $100. I'm trying to withdraw $1,000. This should ignore that. Oh, I don't have a get balance method yet. Okay, that's fine. I can fix that. If you want to use Eclipse to generate your getters and setters for you, like I showed you in class last week, I do not have a problem with that. I honestly end up doing it myself a lot of times just because they're so simple, and I honestly feel like maybe I can do it faster than Eclipse. I don't know if that's true or not, but getters especially are so simple that they don't often require a lot of thought to just chuck them in there. All right, let's test our withdrawal method real quick. I made my bank account have $100 to start. I'm trying to withdraw $1,000, and I want to make sure that that didn't actually go through. So I'm hoping that it still says 100. There we go. Yep, still says 100. Let's test the deposit real quick. Okay, so I want to deposit $100. There we go. It's my WashU payday. JK. If I print out that balance, hopefully we see it go up by $100, and yeah. All right. Just want to do a little check, just make sure that my base class is working the way I expect it to before I proceed on to the remaining parts of this problem. We haven't done any inheritance yet, though, right? The base class oftentimes does not have inheritance involved with it. It can, it's possible, but a lot of times it's just going to be a regular old class. Just a regular old class. Yes?
We're not leaving this class, and so I think why we should use a get balance sheet, like it is still within the scope of.
Oh, you mean why didn't we just say a.balance here?
Yeah.
I guess, so you're correct that I could have coded it up this way within here. I actually don't really see the main method as being within a class so much as just being the main method. I know maybe that's more of a personal view, I guess, than anything, but I generally prefer using getters unless I am directly within a method of that class, a non-static method of that class. Yeah. It's more personal preference. If you had done it that way, I would not be unhappy. I'm just a big fan of using object-oriented accessors when possible. Yep, good question. So let's start with the let's start with the savings account. Let's start with the savings account. So the savings account is an account, right? A savings account is a type of bank account. So inheritance feels like it should work here. So we would say that a savings account extends account. And by saying those magic words, we already get all of the instance variables and all of the methods from the account class just automatically given to us here. So now all we have to do is think about what makes a savings account different and then do that stuff here. That's all we really are responsible for now, right? So what makes a savings account different? It has the ability to compute interest, to give us interest on the account. So what do I need to compute interest? Well, I probably need some sort of an interest rate that I'm going to get paid on. So that sounds like a new instance variable to me. There's my interest rate field. And then we'll talk about the constructor too. That's usually where I like to go next after discussing the fields. So public savings account. Now again, we're using inheritance here, but the role of the constructor is still the same. Have to make sure that all of the instance variables are properly set. So the ones from the base class that I'm inheriting from, I can handle with the base class constructor. And I'm almost always going to do it that way. You can pretty much just automatically come down here, type in the word super, and then we know that we have to pass in a name and a balance. So where are those going to come from? Well, we're probably going to need to take those in as parameters to this constructor as well. So we'll take in the name and the balance as parameters to our savings account constructor, and then just turn around right away and pass those into the constructor for the base class to handle those two instance variables. We now just have the interest rate instance variable left to take care of. That's the one final instance variable that's our responsibility to deal with. And we can deal with that, in any way that we can conceive of for dealing with instance variables. I think a reasonable thing to do would be to just add a third parameter over here. And then set the instance variable this way. Okay? Question? Yeah, absolutely. If I wanted to do this, sure. It's okay. The fields will have the same name, though. The fields that you inherit will have the same name. But the parameters, you can call whatever you want. Any other questions before we... I'm sorry? Did I hear somebody? Did you have a question? Oh, yeah.
Yeah, I have a question still about like this and object. So, if we are using this, whatever object is created in this class, the saving account class, and it is calling the constructor in super and name and balance. So it is going to create another object in the saving account that is same to this one, or it's just gonna have the same instance variables like the ones in sub.
So this is, it's a similar question to the one you asked me about before, calling super versus calling, rectangle, the constructor directly. So if you call the constructor directly without using super, that's going to create a new instance of the object and give it to you, which is probably not what you want in the constructor. If you're using inheritance, it's going to be super. Super is setting the instance variables for you, just like any other constructor would. It's not creating an instance and returning it for you. It's setting the instance variables.
So by using super and two parameters, we are specifically calling the constructor of the super class.
The base class, yes. That's right.
And we cannot call other steps besides constructor.
You cannot call what?
Other steps besides constructor.
You sure can. I just don't know that it's necessary or useful to at this point in the program.
I just wonder if there could be confusion if some method in the superclass also require two parameters, one string, one double. How could that Java tell? Like,
But if I'm calling a method from the superclass that's not the constructor, then I'm saying super dot method name,
oh, I get it.
right?
Yeah.
This one doesn't have a method name associated with it. That's why it's the constructor. Any other questions? Great questions today. I know this is a tricky concept, so I'm happy to hear the questions coming in. Happy to answer any of them that I can. All right. So the only other thing I can think of that we may want to do here is we need a way to compute that interest, right? And actually factor it in, compound the interest on this account. So I think that would require a method. You know, there's some math here, right? This, you'd have to multiply the interest rate by the balance and then add that back. I'm not worried about the math. I'm worried about the inheritance. I'm not even going to type the math out. That's how not worried about the math I am today, right? I'm more worried about the inheritance piece that says I can pull in the stuff from the base class and then define whatever unique behaviors I need in the subclass. So this is something that a savings account can do, but not every bank account can do, right? It can compound interest. Any questions before we move on to the checking account? So I'd like to do that one as well. Okay. So then let's switch over to the checking account. What we said was different about the checking account is that it allows us to overdraft. So if I want to, I can go into the negative. I can put my balance into the negative, not to infinity, right? There's still a limit. So they won't let you overdraft as much as you want. It's usually not even that much. It's usually like $50, $100 or something, you know. You can't take out however much money you want. And then also, if you do go below zero, they're going to charge you a nice fee. They're going to, you know, ask you for money because you went below zero. It's a service they provide, right? They're basically giving you a short-term loan that they want you to pay back with extra on top of it. So what does that mean for our checking account? That means that I think there needs to be perhaps a new field for the fee, perhaps. Or if the fee is constant for everybody, then maybe this doesn't need to exist, right? There's just every overdraft is $5 a piece, then that's fine. This is nice if you want to allow the fee to change depending on what kind of account it is. Regardless, we are going to try to allow overdrafts to occur. We need to discuss the constructor again. However, I'm going to go through it kind of quickly because it's a similar conversation to the savings account constructor. We're going to pass in the two parameters to the super constructor like we did before, and then handle the remaining instance variable ourselves. So it's going to look somewhat similar to the one that we did for the savings account. What did I do wrong here? Oh, I know what I did wrong. Anybody see it? Anybody see what mistake I made? Why is Eclipse angry at me right now? Yeah. I didn't extend. Yeah. So here I said, hey, go look at the base class. And it's like, you didn't tell me about any inheritance. You didn't tell me about any base class. I don't know where to go look. What are you talking about? I forgot to come up here and extend. This super keyword does not make sense unless you're using inheritance. Okay. So I want to allow people to overdraft. I want people to allow people to let their balances go below zero. This applies to withdrawals, right? When I withdraw money, I'm now allowed to draw more money than I actually have. That's not how we had the withdrawal method drawn up in the first place, right? Here, it's only letting us withdraw money if we have enough to cover it. We want our checking account behavior to be different than that, though. So what do we have to do? It's a word that starts with an O. Override. We're going to override the withdrawal method because we want the behavior for withdrawals to be different for checking accounts than we do for other types of accounts. We want to allow for overdrafts. So let's go back to our checking account and we're going to override this. Okay. Let's say we want our overdraft limit to be $50. We'll allow somebody to go $50 below their balance, right? So that means that if the amount minus 50 is less than this dot balance, we should allow the withdrawal to go through. Why is it unhappy about this? This is exactly how we wrote it in the base class, right? Less than this dot balance. Why does this dot balance work here, but this dot balance does not work here? Yeah. It is. Yes, the balance instance variable is private. That is exactly right. How do we fix it? Make another instance variable? Not quite. How do we fix, yeah. A getter, yes, a getter. Actually, I think I already have one, right? I just didn't use it. I already have one, I just didn't use it. There's actually another solution to this problem that you'll learn in more advanced comp sci classes someday. But for now, using a getter is great. There we go. This is some more math that I'm honestly not necessarily concerned about, right? You would do the withdrawal, but then you'd also have to remember to take the fee along with it if the balance is negative. If my balance is negative at the end of the withdrawal, then I need to take the fee out too. Right? I'm not going to do the math. You can work through the math. This is inheritance day, so I'm not worried about those kinds of low-level details at this particular moment. More interested in the fact that we've defined a different withdrawal behavior for our checking account than for the other types of accounts. That's important. That's useful. So I'd like to tie this all together with one final code example. Where do you find accounts? You typically find them at a bank. Find them at a bank. And a bank, how is a bank going to decide to organize those accounts? Well, if I wanted to, I could make an array of savings accounts, right? Or if I wanted to, I could make an array of checking accounts, right? But if I made arrays of those types, I could only put savings accounts into them, or I could only put checking accounts into them. And I know I'm going to have some of both, plus other types of accounts that we didn't even do, right? If I make an array of type account, that's the base class. A savings account is an account. A checking account is an account. So anywhere that I see account given as a type, I can also use savings account. I can also use checking accounts. So that means that I can put checking accounts into this array. I can put savings accounts into this array. I can put regular accounts, base class accounts into this array. I can put anything that inherits from the account base class into this array. Does that make sense? It's a powerful, powerful, powerful technique. Up until now, we had no way of putting objects of two different types in the same array. It was not possible, right? And now we do. We have to use inheritance to pull that off. So I think this is a great tool. But even further, let me, so I'm not going to actually code up a whole lot of the bank class. We don't have a whole lot of time left, actually. But let me do a couple more things here to show you the power of this. I'm going to make a savings account and a checking account real quick. If I can type. I don't honestly care what these actual numbers are for the purposes of this example. They're not going to affect much. This is a fee, so okay. Check this out. I've made a checking account. I've made a savings account. I now wish to make an account array. This line of code right here, right? This line of code right here is kind of the payoff for everything that we've been doing today. This is a savings account. This is a checking account. Two different types of objects, both in an array, the same array of type account. Not only that, so you can, I only made 2 accounts here, right? Because I don't have all day to make tons and tons and tons of bank accounts. But if you went to an actual bank, they would have tons and tons and tons and tons of actual bank accounts, right? Let's say, for example, that I'm at a bank and I want to I'm feeling generous. I'm sorry, I'm feeling the opposite of generous today, and I want to withdraw $10 from everybody's account. I don't know why a bank would do that. Well, yes, I do. Banks are not known for, well, never mind. Yeah, I want to withdraw $10 from everybody's account. Okay. Let me write a loop. I'm going to write a loop that's going to iterate through this array of accounts, and it's going to extract an account out of the array, right? Stick it in a variable, and then call a.withdraw 10. I want to withdraw $10 from every account at the bank. But let's think about what this means since we have inheritance here. Remember, we have 2 versions of the withdrawal method. One from the account class, the base class, and one from the checking account class. Here, in this code, I'm looking at the variable called A, right? I know that it's an account, but I have no idea if it's a savings account or a checking account. I just know that it's an account. When I call this withdraw method, however, it will actually determine, are you a savings account or are you a checking account? And choose the appropriate withdrawal method based on what it actually is, based on the actual type. So if A is actually a savings account, then it will use the withdrawal method from the base class, since savings account did not override it. If A is actually a checking account, it will use the withdrawal method from the checking account class, because the checking account class did override it. So think about what that means. That means that I can treat a checking account either as a checking account, or I can treat it as the more generic base class account. Both types are valid. This is a very important concept. We have a name for it. It's called polymorphism. So polymorphism is a very long, complicated sounding word that really just means that we can treat objects differently in different contexts. And that's the example that I tried to illustrate for you all the way back at the beginning of class. I am a person. Right now, I'm being treated as though I am an instructor because I'm sitting in a class teaching a class. But when I go home, yes, I am still a person, but now I am no longer an instructor. I am a parent, and I'm going to be doing parent things. I'm still the same object. You can treat me as the parent type. You can treat me as the instructor type. You can treat me as the person type. All of those types apply to me, the same object. That is polymorphism, the idea that one object can have different types in different contexts. Does that make sense? It's a hugely, hugely important concept. That's a lot of what makes inheritance work. It's a lot of why we use inheritance. I know this stuff is confusing. I know it's complex. It's very abstract. Objects are already abstract. And this just makes things even more abstract. So I understand that this is probably going to need to take a few laps around your brain before it kind of sinks in. Practice is going to help. So if you haven't already, please keep writing code. Keep doing as many practice problems as you can. But that's all I have for you today. So we'll go ahead and wrap up a few minutes early. If anybody has any questions, happy to stick around for the last few minutes and answer any questions you have. Otherwise, I hope you all have a great week, and I will see you in the labs later this week for studio, okay? And keep an eye out for those exam grades later tonight or tomorrow. Thanks, everybody.